Okay, so now what we're going to do is worksheet 3, problem number 5. So reading this, I know that I have a full bag of ice, which is 450 grams. And as soon as I see that, once again, I know that mass is 450 grams. It gives me something about 0 degrees Celsius. But I quickly scan it, I don't see any other temperatures, so I don't know if I'm going to use that or not. But I'm going to label that as my temperature. Sits on a counter and begins to melt. So here's the key word, is it's melting to liquid water. How much energy must be absorbed for all the ice to melt? So I think about the graph that I'm going to need to be using, and I know that it's melting, so it's undergoing a phase change, which means that it has no temperature change. So this is the graph that I'm going to need to use. Now I look at my two equations, Q equals MCAT, or delta T, where there's a temperature change, or I'm going to use Q equals HM. Now in this case, because it's a phase change and there is no temperature change, I have to use Q equals HM. So now I know my M, and H is a constant, and it's a constant for water, they have a constant for almost every single compound out there. It just depends on what that particle or that compound is. So for water, if you reference the front of this page, you would find that H's value for water, because that's what we're talking about, for the process of melting, which is fusion, is 334 joules per gram. Okay, so now I know both my H and my M, so I'm ready to solve. So Q equals HM. So I'm going to plug my H value in, which is 334 for water, and I'm going to multiply it by my grams, which is 450, and I'm just going to multiply it out, and I get 150,300 joules. Now regarding sig figs, I look at all my sig figs. 450 has 2, 0.0 has, I don't know exactly how, but I guess you would say 2. And so we're going to round to 2, so it would be 1, 2. So this would round to 150,000. That's supposed to be a 5. 50,000 joules.